Hello, I thought I might do a series of what I might call a waterside chat. I like a fireside chat, but this is water. I'm actually on my boat, and I've spent the last few weeks sorting out every little system from the mains electricity to DC, getting batteries sorted out, crawling here and there and following bits of tubing and bits of wiring and so on. I got most of it working, except the water. I think it's fair to say I've got what you might call a self-documenting boat. So those of you that do software code and stuff, you're familiar with the idea of self-documenting code. In other words, I don't need to document it because somehow everything's obvious. Well, it's kind of the same with a boat. I've got all these systems, and if you crawl through and follow this piece of wire to that place and follow this piece of tubing and see where it ends up and so on, you can figure out each little system one by one, but there's still things that I haven't been able to find. And it's not a problem with commenting. Lots of switches have got little comments on. This one says windlass, and this one says inverter, and so on. And yeah, all the commenting's there. And I still have to crawl around on my knees and find everything. So yeah, a little bit like software. We think about software engineering as though we're thinking like engineers, but in most branches of engineering, you kind of start out with some kind of documentation of what the real people want that are actually paying you to do this stuff. And, they can make decisions on budget and risk and, profit and loss and so on based on what it costs to do a thing and what it is they want you to do. And it's all documented. Somehow with software we don't always do that. So I guess this is kind of how I got into the whole well, eventually I got into the ontology stuff, but I'll come to that. But really the basic thing here is what we call quality assurance. And I've been having a few conversations recently where you've got an organization that has all this great technology, and they have a thing they do and it produces the result and everything, and it's all lovely. But what's missing if you don't have, well, the watchword in quality assurance is what we call demonstrate control. You need to be able to say what you're going to do the thing you said you're going to do in a repeatable, formal way, and then demonstrate that you did the thing you said you were going to do. Now, it might be a good thing or a bad thing. It's usually a good thing, but quality control doesn't mean everything's top quality. Probably the best quality assurance system on the planet, I would imagine, is probably McDonald's. The burgers are not terribly good, but they're always exactly the same, and there's a value in that. You know what you're getting because you know the process, and you know that the process is completely repeatable and completely auditable. So, for example, you might have a whole kind of GitHub set up. You've got your, you got your source code, and you kind of branch when you want to make a change, and you do your changes, and you do a commit, and you get a nice bit of red line that shows you what's added and what's removed, and so on. And people can review that, and then you commit it, and so on. And that's great. You've got that audit trail. You've got that ability to demonstrate control. But if you're not actually recording that, if you don't have some way for business oversight to say, well, okay, did they review that code? Who reviewed that code? On what kinds of things was it reviewed for? Code consistency? Was it reviewed in terms of our in-house programming rules or conventions or whatever? Was it reviewed to ensure that it was properly documented? Was the spec the same as what the thing did that was meant to meet that spec? So it's not enough just to have a nice kind of GitHub type of system. You've got to have some kind of business structure. This is stuff outside of IT itself. Something the business itself owns the problem and owns the budget for getting somebody to create the solution to solve that problem. So you need to be able to know that when this pull request was done, this kind of review happened. Maybe you've got a subject matter expert looked at a thing, particularly if you're looking at something like an ontology resource rather than source code, for example. you need to know which kinds of check were done, and you need to have had a process that says these are the checks that are done, and then an audit trail that's comprehensible to business, not just, oh, go look at tag number XYZ123578 and you'll see all the code that we did, and it's all there. It's got to be comprehensible to business. So that's my thought about self-documenting boats, and I think kind of I mentioned before, this is how I got into the ontology game, is when you look at how you define the requirements for what software does, you're looking at what we call behavior, the behavior requirements. It must do this, the user sees this and they must do that, and so on. You're describing behaviors, and that's well understood if it's not always necessarily well implemented. What about data? What about that which is rather than that which does? And these are the two sides of any kind of engineering problem, the structural and the behavioral. So the structure, the data. What's the equivalent there for having a business-facing view? So over the years, I've been working with various standards bodies, and I came out of engineering originally, and that whole quality assurance thing, applying hardware disciplines to software, basically solid change control and auditable process and so on, QA, ISO 9000 type of stuff. So when I was looking at various industry standards bodies, this is way back now, you have various messaging standards, and you get all these subject matter experts around the table, and they tell you, this is what a payment process is, this is how you do, this whole kind of chain of payments and so on, or this is what a equity security is like, these are the terms that it has, and so on, here's the reference data. You get all this knowledge from the business people, it goes straight into some kind of UML model or some XML schema or something, and the business knowledge is lost because already you're designing something, you're finding nice reusable chunks of message structure or reusable class structures that can carry data for more than one kind of thing if they're well designed. And so you suddenly have to know, here's a class that has hundreds of properties, and this property only exists if it's an equity, and this one only exists if it's a debt instrument, and this other property only exists if it's this kind of swap or something. And you might have one big class for security and another big class for derivative or for swap or something, and lots of optional properties, which is good design because you want to be able to reuse these structures. But then the knowledge is gone that you got from those subject matter experts who went straight into the thing that says, oh yeah, okay, we know what one of these things is, and we know what terms it has to have. Right, here's a class with lots of optional terms. Where's the knowledge that says which terms need to be populated for which thing? How do you hand that off to a programmer to say, write me some code that will take in all these bits of data that are happening and populate the data for this message feed or this kind of thing. So you've got to really track the knowledge independently of the implementation of it. So again, it's like the self-documenting boat. If I had a circuit schematic for the AC and another one for the DC, if I had diagrams of the all the bits of important tubing and what the heck they do and so on, a human view of what the thing is, then when things go wrong and this light doesn't come on or the bilge is filling up, and it was quite a relief when I connected something and the bilge started emptying. That was a lot of water. So this is where you need some kind of view for the data side of things of what is the meaning of things. And that's kind of how I got into ontology. It wasn't about having all the wonderful things you can do with ontology solutions. It was about applying more of a cognitive science kind of view, like, how do we define the meanings of things? How do we think about, if you've got a whole set of terms, if you define one of them, you define the others in terms of that. How's the meaning grounding? Or to paraphrase John Searle, where does the meaning get in? How do we have internally consistent structures that we know are internally consistent? Again, being able to audit and demonstrate these things. And that's partly where with ontology you have things like reasoners that prove the thing is not inconsistent. Doesn't mean it's meaningful, but it proves that it's not automatically not meaningful. You still need a lot of human review. If you're branching an ontology and adding stuff. But again, with ontology, if you've abstracted everything right, then most of your changes should be additive. But then how do you know that the right subject matter experts have looked at that? How do you know that it's consistent? You haven't just reinvented a term that's just like this other term because you couldn't be bothered to find what the other term meant, and so you start to fragment the sort of network of meaningful concepts. That could happen quite easily. How do you know when to use a more abstract concept? How do you know when to add a more abstract concept higher up in the tree that wasn't already there? How do you consistently apply, for this ontology framework, there might be a particular way of dealing with time and temporality, or a particular way of dealing with, four-dimensional flows of things through time and space. There's always going to be a set of rules. How do you know those are applied correctly? So, again, you need to ensure that the right kind of reviews, both from a subject matter point of view and from a ontology concept integrity point of view, has all happened. And that concept stuff, it doesn't emerge out of getting the ontology code right and having all the right restrictions and stuff. It has to come from a human point of view, a cognitive science point of view. How do we think? How do we form meanings and so on? So that's how you try and have that quality kind of process where you can demonstrate control all the way along, understand who has looked at what, so that you know that the end result isn't just great, these clever people did this clever thing and it was wonderful. We almost sometimes treat IT as a blame center, like if it's not as good as they say it is, we can go and give them a kicking or something. That has no business value. If you want to know that the business is in lockstep with the technology that they're deploying, then you simply need to be able to have that kind of auditable, repeatable process that flows up to the business and is described in business language and so on. And then you can have a seal of approval on that thing. You know what there is and so on. So while I'm on the boat, there's lots of wildlife around here. I saw an otter swimming along this morning on my way to the shower block. I said before, the taps aren't working on the boat yet. A couple of seagulls and a few seals out and about the place. So I was talking about how you can give something a seal of approval. Self-documenting code, self-documenting boats. They give you what I'm going to call the seal of disapproval. I hope you can see that there. So thank you for watching, and until next time.